Welcome to ProDesign 3D Revit plugin software demonstration, showing the features and benefits of integrating ProDesign 3D into your company workflow. Once you've installed and completed the ProDesign link, you will see and be able to navigate to the ProDesign 3D tab within Revit. Once in this tab, you'll see many icons you are familiar with from ProDesign. On the left, we have the Project Settings button. When opening the project settings, we're again presented with many familiar settings from ProDesign. Here, you have the ability to use Revit information to populate the fields, or are able to select Override to update and change any information. I will select the override for these fields as this information will show up in reports. Remember, when using the override setting, the information is stored only for ProDesign 3D. It is not sent back to the Revit model. Under this project area, we have comments and revisions, a useful tool which allows you to write down the work that has been carried out during the Revit session. Moving on to calculations, we have the minimum cable sizes, in the same way that you do within ProDesign. You have the flexibility of selecting minimum cable sizes for that type of equipment. You can select sockets to a minimum size of 4 mm squared. As you can see, the separate circuit protective conductor minimum size has also changed to 4 mm squared. This can be updated and modified if necessary. In this instance, I'll keep it at 4 mm squared. Another feature similar to ProDesign is being able to set the maximum CPC sizes, which by default is set to 3 sizes above the phase conductor size. Like ProDesign, we can also select diversity and define the load thresholds which operate in the same manner. Another important feature that we've brought into ProDesign 3D is the largest device list approved by manufacturers. Just like ProDesign, the user can create a short list of their preferred manufacturers and then easily select the protective device of their choice. For this demonstration, I'm going to use some generic devices. A feature that we've implemented specifically for Revit are the assigned spaces. This is a great feature which takes the spaces that have been designated and add it to the Revit model and allows them to be assigned to the board. We've allowed the flexibility to the user to specify the percentage of the board for that particular space, which is really useful for large spaces. They might be supplied by multiple boards or a single board supplying several spaces. I'm now going to assign Reception Lobby 50 to the main power board 1 at 100%. Another Revit specific feature are the Revit mappings. Here we can select Revit wire types and assign them to ProDesign 3D cable types. The 4E1 cable type isn't currently mapped, so by selecting the Revit wire type 4E1 non-armoured single and then navigating to the relevant table in ProDesign 3D cable dropdown, I've mapped the Revit wire type to the ProDesign 3D cable type. Now I'll go ahead and map the remaining cables. Similarly, we can map the Revit load classifications to the ProDesign 3D load types. On the left, we've got the list of Revit load classifications, and I'll select the socket and change the single phase load type from a radial circuit to a ring circuit. Moving across the ProDesign 3D ribbon, I can edit supplies. This will bring up the list of equipment that's been considered as a supply. Transformers are always considered a supply and will be shown on the top half of the dialog. Other equipment, such as generators, switchboards and distribution boards, will be shown at the bottom of the dialog, thus providing that they are not connected to any upstream equipment. Just as an example, we now see North switchboard. If I select the North switchboard and connect this to the main incoming transformer, and now going to edit the supply, you'll see that the North switchboard is no longer listed. If I click on the pencil icon on the transformer, this will load the main supply settings. Here, I can change a variety of parameters, but will not modify these as they've already been defined. Providing the electrical equipment is now connected in Revit, we can modify their settings by clicking on the Edit component. To start with, I'll connect the sockets in the office area simply by selecting them. Assign them to power and then selecting Main Power Board 2. These sockets are now connected to the board. If I go ahead and select one of the sockets, then go into the ProDesign 3D tab, I can now edit that component. This brings up the final circuit settings dialog, which opens up into the protective device selection. I'm going to go ahead and change the protection from a fuse to an RCBO because this is a socket circuit. I can then change the volt drop limit settings, but for the purpose of this demonstration, I'll just leave it within the global settings. I can modify the cable settings, and as you can see, the cable has been brought through as per the Revit mapping definitions in the project settings that we set to begin with. I will change the installation method to be in suspended metal trunking, and I'll leave the cable sizing rating as auto. The length will be obtained from the Revit model, but this can be overridden if necessary. Keeping in mind the overridden value is not replicated within the Revit model. It's purely for the ProDesign 3D calculation. I'm going to leave the Revit value as is. We can then move on to grouping. I don't have any power cables in parallel for this circuit, but I can expect to have a total of 2 group circuits. I'll then leave the CPC to be sized automatically. Finally, if we look to edit the load details, and we can see that because I've changed the Revit load classification mapping, we've got the ring final circuit shown. I'm not going to make any modifications to the remaining settings. What I'm going to do now is update the load name to Office Area 3 Sockets. I'm now going to go ahead and edit the settings of a distribution board. I'll select this particular board, go into the ProDesign 3D tab and select Edit Component. Again, this will be a dialog that ProDesign users will be very familiar with. We've ensured consistency between all versions of our software. Opening the dialog, we have the board details showing the method of wiring and the number of ways which have been brought through from Revit. There are also some fields I can populate. I'm going to set the load rating to 125 amps and the fold rating to 25 kA. The remaining fields can be populated as and when the information becomes available to you. Because I've given the board a load rating of 125 amps, I will set the isolating switch also to 125 amps. I can select the default protective device, and because I expect most of the circuits on this board to be socket circuits, I'll change the default device to an RCBO Type C32 amp. This is particularly useful if we know that there's going to be several of the same loads connected to the board. Under diversity in the board loading method, I can select the type of load diversity method required. I can select manual settings, which allows me to edit the diversity of each phase if I unlink the phases. I can select define load, which allows me to assign a specific load current, power factor and third harmonic across the phases. Or I can define these for each phase, again by linking or unlinking them. For this demonstration, I will set the load diversity method to manual settings with a diversity of 1 for each phase. Within circuits, we can review all the connected circuits on the board. I can also easily navigate to the panel schedule by zooming and panning, and it's a nice simple view that allows us to easily see and edit what's connected to the board. I can also see the type of protective device selected, as well as the final load type by looking at the table. A slight difference for those of you that are using ProDesign 2016 is when clicking the table. These values are not automatically added and must be correctly connected in the Revit hierarchy before they appear on the board. All the settings for this board are now set. The last connection I'll make are the lift lobby cleaner sockets, which were made to this board. Once more, assigning these sockets to power and selecting the SP North panel, I can select a socket and edit the component. Here you see the different device has already appeared as per my default protective device settings. I only need to change the cable, so by hitting override I can select the cable from table 4D5 and adjust the installation method to be in a plastic conduit. Finally, in load details, and because of our Revit mappings, this is set to final ring circuit. These are cleaner sockets, so I want these on a radial circuit. Again, if I select the override, I can scroll up to a radial circuit, remembering that this is only for ProDesign 3D. I've made all the modifications I need to now, and these are all okay. You may have noticed I skipped the Assign Spaces section when modifying the distribution board. Although I've discussed it already in project settings, I'll now show the other method of assigning spaces here. I'll select Main Power Board 1 and go into the Edit Components dialog. By selecting Estimated Load under the Board Loading Method screen, this will show me the estimated load for the area. Here we can see we have 3 options: by floor area, by load category and also by space. Using by floor method, we can set the size of the floor area, define the watts per meter squared and then modify the power factor. As I'm changing these values, you can see that the maximum demand is changing and updating as we go. If I move on, I can set by load category, which allows me to add different load types. For example, I can add heating, change the load current to say 10 amps, and update the power factor. I can add as many relevant loads as I need to, and this will continue to update the maximum demand for me. Lastly, moving to by space, I can see that there's already a maximum demand placed on the board of 9.5 kilowatts. This is split roughly between 5.5 kilowatts of power and 4.2 kilowatts of lighting. These values have been assigned because early in the project, within project settings, we had assigned the reception lobby to this particular board. If I click on Assign Spaces, here we can see the reception lobby is already assigned. I'll assign the male WC13, female WC14, and space 45. If I go back into estimated load, we can then see the maximum demand has now increased by just under a kilowatt to 10.47. Going back into Assigned Spaces and set reception lobby to 50%. The estimated load, we can see from the previous value of around 10.5, has now drastically reduced. If I want, I can also check whether or not I want to include power or lighting. It's also possible to do that just by clicking these boxes, and you can see the maximum demand is always changing. I can also see if there's other HVAC or other types of loads. Now this model is all connected up, I'll get ProDesign 3D to perform the calculation by clicking on the button for Calculate. Now we can see there's a couple of errors here. First thing I'm going to resolve is the RCD error. It's telling me that the RCD protection is required for the socket outlets. Clicking on the binoculars takes me straight to the area of the problem. With the board selected, I'll click Edit Component, go into Circuits, and I can immediately see that the protection for way 2L1 or circuit 4 is an MCB. Because it's connected to a socket circuit, we really should have an RCBO here, so I'll update this to a 32 amp RCBO. If I just run the calculation again to make sure this error is clear, you can see that the RCD error has actually disappeared, so that's good. I've got another error here for the air handling unit, and it's a cable sizing error by the looks of it, and it looks as if the tabulated current isn't quite suitable for this load. Pressing the binoculars icon once again, it's highlighted the area. So I click onto the air handling unit and go to Edit Component. What I'll now do is click on the cable. This error is occurring because it's the sizing to a manual at 4mm squared. So I'll set this to auto and press Calculate again. As you can see, I've got a couple of warnings and a couple of notes. The notes are saying that some cables have been upsized because of the volt drop, and the warnings are just telling me that some of the circuits, the phases have no loads, but I'm expecting loads to be connected at a later date further on in the project. Now the calculation will be carried out, I'm going to run some discrimination and do a study to see whether any other errors occur. Okay, we've got two errors here. If I click on the binoculars for the first error, it takes me straight to the connection between south switchboard and the north switchboard. If I select the south switchboard and press the View Graph button, and I want to view a time current graph, it's going to show me devices upstream of the south switchboard. This loads up the Protect interface. What you can see is that we do have some discrimination issues between the various devices. By selecting the devices individually and modifying the selective short circuit on the keypad, you will notice the curves are being adjusted. Now, I've made the necessary adjustments. I'll hit Save and Exit and run the discrimination study again. We should now see that the errors have cleared. What this is now showing you is that you can perform a discrimination study in ProDesign 3D without having to go back to ProDesign. The modifications I've made here are looking good and those errors have cleared, so we can move on. Moving across the ribbon again, we have the Protect button. This allows the user to select a piece of equipment, export the devices as a Trimble Protect file. This is a really useful feature, I think, which allows the Revit user to export a file to an engineer who may not use the Revit model but may want to check the settings in Protect. I can also select from a range of reports that have been brought through from ProDesign. For example, if I want to produce a cable schedule, I click on Reports, select Cables and select Schedule. I want to show all the cables, so leaving everything selected, I'll press OK. As you can see, through our report engine, this will load the display of the cable schedule. These can all be exported to various formats such as PDF, Excel, or even a Word document. If I now move on to the Revit panel schedules, I have access to several shared parameters, which allows the setting up of a custom schedule. I'm going to edit the north switchboard, and you can see I've entered a selected few of the Trimble share parameters. Here we can see a vast array of the Trimble share parameters available to all our users. To give an idea of what this schedule looks like with the parameters populated, I'll open up the north switchboard and see what we've got. The Trimble max ZSs, actual ZSs, CPD ratings and the load current values are all shown. The final button for the version of the UK ProDesign 3D is Generate Schematic. By pressing this, I can actually export the model as a ProDesign file. I'm going to quickly open this project in ProDesign, which then allows me to print and issue the schematic as I normally would do when using ProDesign on its own. Generating a schematic also adds the ability for non-Revit users to check the way the electrical distribution network has been connected within the Revit model. That concludes this presentation for ProDesign 3D, so if there's any questions, feel free to ask. Thanks very much.